Hi, everyone. Hello and welcome to Adventures in Bird Molt, Finding Fun in a Forbidding Yet Fundamental Process, presented by Peter Pyle. I'm not sure if you guys can see me, and if you can hear me. If not, let me know in the chat. My name is Meredith Walker, and I'm the Communications Specialist for the Institute for Bird Populations, and I'll be serving as the host on Zoom for this webinar. We are so glad you could join us. If your mic is not muted, please do so. You might want to check it. Should have been muted when you came in. All right, sorry. Before I introduce Peter, I would like to introduce our organization to those of you who might be unfamiliar with it. Let me just share my screen briefly. And all right. The Institute for Bird Populations, or IBP, is a 501c3 nonprofit founded in 1989 to study the causes of bird population declines. Let's see here. Sorry, folks. There we go. We'll get the hang of it. The Monitoring Avian Productivity and Survivorship, or MAPS program, was our first major initiative and is our best known program. MAPS gathers critical information about the health of bird populations on their breeding grounds using data collected at bird banding stations. We also run a sister program monitoring bird populations on their wintering grounds in Latin America and the Caribbean called El Monitoreo de Sobrevivencia Invernal, and it's abbreviated as MOSI. So this map shows some of our station locations for that program. Over the decades, our work has expanded well beyond the MAPS and MOSI programs. We collaborate locally, nationally, and internationally with government agencies, universities, and NGOs to assess the effects of climate change, land management actions, and other ecological stressors on populations of birds, and more recently, pollinators, and to prescribe practical solutions to conservation challenges. We also offer training in bird banding and conduct studies on molt and plumage, which is where tonight's speaker comes in. If you want more info on IBP, visit birdpop.org. As I mentioned earlier, we are a nonprofit, and if you were inspired by the webinar today and would like to support our work, please consider making a tax-deductible donation. I will put a link to our donations page in the chat panel. So now let me introduce our speaker. Peter Pyle is a world-renowned expert on molt and feathers. He has written over 100 publications on the topic, including numerous scientific papers, as well as engaging articles in Birding Magazine and elsewhere. And most notably, he is the author of the Identification Guide to North American Birds, which serves as sort of a bird bander's Bible in this region of the world. Note, Peter is currently working on a second edition of this guide, so if your copy is a bit beaten up, stay tuned for the revised edition. Peter has been a biologist with IBP since 1996 and is a research associate at the California Academy of Sciences, and recently received a 2020 Individual Investigations Award from the Partners in Flight for his work on avian molt and its application in bird systematics, demography, and conservation. So I promise to stop talking real quick, but I need to mention a few procedural items. Here we go. First, the webinar is being recorded and we will post the recording on our website. So if you miss anything, you will be able to go back and see it. Second, when you joined us on Zoom, your microphone should have been automatically muted. Please keep it that way unless I tell you otherwise. Supposedly there may be over 700 people on this Zoom session, and so it will get confusing if we're all making background noise, etc. And lastly, Peter will be answering questions after the presentation. Please ask your questions in the chat window. If you're not familiar, you should see at the bottom of your Zoom window a little icon that says chat, and you should be able to click that and you'll see a panel where you can send a message and ask a question. I will be keeping track of your questions and consolidating them so that Peter can answer them at the end. Lastly, if you're hard of hearing or having trouble with the audio, there is a live transcript available. To enable it, look for a button at the bottom of your Zoom window. It should say CC, closed caption options, and it might be under the icon that's 3 dots that says more. But warning, the live transcript is being produced by a computer that is probably not going to recognize some of the more technical terms used in this presentation, so there's going to be errors. And now I would like to turn this over to Peter.
All right, are we good, Meredith? Can you hear me?
I can hear you.
All right. All right, well, welcome everybody. I see lots of hellos from around the world, and I'm honored to be able to address this subject with everybody. And I will note that it is a little North American centric, but I'll try to be gentle, especially with things like molt terminology. So I've got a lot of slides. I'm going to go pretty quick. I'm going to try not to go into too much detail. Usually I run long. We do have 2 hours. I'm going to try to finish within about an hour, and then have time for questions afterwards. So sit back and enjoy the ride. Here we go. Let's see. Somehow my thing's not, there we go. Okay, so I don't know if you guys can see this. Hopefully you can see my cursor. Is this in the way, Meredith, of the Zoom screens? All right.
Sorry, I don't think so.
Okay, good. Can you see my cursor?
Yes.
Great. Okay, what is a molt? Let's start that. It's a process that's still, despite lots of studies, rather poorly understood. And some early ornithologists recognized that molt is not just replacement of feathers, because that's what we all think. It's actually was described in 1924 as a profound disturbance of endogenous metabolism. And then Murphy and King in 1991 described it as part of alterations of whole body protein metabolism. So the important thing here is that the molt, at least the primary molt, the pre-basic molt that birds go through annually, is not just replacements of feathers, but it's a whole process. And I think it's a rather restorative process. And I'll get to that in a bit. Let's see, I'm not, all right, I guess I have to hit this. So what we do is when we're describing molts as birds, is we describe it as at least a few feathers are replaced regularly within the annual cycle in at least a few individuals of a species. So it is part of a process. Not all molts are part of that fundamental endogenous process, but at least for the purposes of defining molts, this is the definition we basically use. So what is not a molt? Not a molt is when a bird accidentally loses feathers, like its tail, or this Wilson's warbler somehow lost a bunch of secondaries and primaries and managed to survive. You can see they're newer and regrown. So that's not a molt. There's this term adventitious molt, but I prefer not to call it molt, just replacement, because it's not really part of a molt process. Another thing that's described as molt is fright molt, and that's where birds will lose a lot of body feathers when a predator is about to attack them, and that's a predator avoidance strategy. But that's not a molt either. So again, I would describe that as a feather loss process, not part of molt. Okay, so when I started studying molt back in the 80s or 70s even, I came across all these terms for molt, and I wrote them all down and tried to figure them out. And basically, even myself, along with all the other top ornithologists and some very smart people in the world, just couldn't kind of grasp it. And what this led to was a fear of the subject of molt. It was so convoluted with terminology and so tangled up that students of ornithology would avoid studying molt. They go into breeding or breeding systems or migration or some other topic. So the study of molt has really lagged behind that of other subjects due to this fear. Now, I'm an adherent of the Humphrey Parks terminology, and I'll be explaining that pretty thoroughly in this talk. It's a terminology that's not just based on when and where and how many feathers are replaced during molts. All of those things are plastic. It's instead based on how molts evolved from ancestral lineages. And this is very important to know. So what Humphrey and Parks, or to understand, what Humphrey and Parks set up was what they called a cycle-based terminology. So most birds undergo a single, rather complete, it's usually complete, but almost, even if it's not complete in some larger birds, that's only because they didn't have enough time to replace all the feathers, and we'll get to that. It usually occurs after breeding. So when the birds are worn, beat up from breeding, they then take a break and molt their feathers. And I believe that this is the molt that's part of the restorative endogenous process. So I kind of liken it to taking a vacation for us. The end of July, we're all beat up, whatever. We take August off, take vacation, and then get restored for the fall. So it's kind of like birds do that. Now, this pre-basic molt basically occurs annually in almost all birds. There are some birds that have sort of been thought to have cycles that aren't a year in length within the adults, but I don't think it's well enough documented at the individual level to say that pre-basic molts occur once per year. They're usually complete. They usually occur after breeding, but there's exceptions to all of those things. So the important thing with Humphrey Parks terminology is to understand that the pre-basic molt has evolved from reptiles. So birds evolved from reptiles. Reptiles also molt. It's called ecdysis. This is the molt of a reptile. And we believe, we're pretty sure now, that the molt of birds has evolved directly from the molt of reptiles. And again, it's part of this alterations of whole body protein metabolisms that occurs throughout all vertebrates, actually. So it makes sense that bird molt will have been part of this process and evolved directly from reptiles. So that means they kind of evolved from dinosaurs, because we all know that birds evolved pretty much from dinosaurs. And now just recently, we're starting to confirm this in various studies of fossils of what do we call feathered dinosaurs, or the species, the taxa in which dinosaurs were actually evolving toward birds. So this paper by Joseph Kiat in 2020 shows that the dinosaurs' feathers in the wing basically molt in a similar way to the bird feathers do now. So that kind of is one of many pieces of evidence that suggests that the molts of dinosaurs evolved directly into the molts of birds. So recently, I was in on a paper with Joseph to help clear up molts in Archaeopteryx. So that's there. And by the way, I'll be showing a lot of papers during this thing. And if any of them strike your fancy, they're all available at our website to download PDFs for free. Most of mine are there, I think. So if you go to here, you can download these papers that you'll see throughout this talk. Okay, so we've got the pre-basic molt defined. It's usually complete. It's usually occurs after breeding. Now, along the evolution of birds, other molts have evolved within what we say within the pre-basic molt cycle. So the pre-basic molt cycle in adults occurs from the beginning of one molt to the beginning of the next molt. And some birds will have evolved molt within those two. And this is called, in Humphrey Parks terminology, the pre-alternate molt. Now, the pre-alternate molt is usually, there's only a few examples around the world where this molt is also complete. By and large, the pre-alternate molt involves just body feathers, sometimes some tertials, which are feathers that really get worn out a lot, so need to be replaced. And in some of the famous examples, of course, there's the scarlet tanager, where this is an adult male on the wintering grounds in the fall, late fall, and then he molts completely red feathers by the spring. So they leave the United States or North America in this plumage and come back in spring in that. So within the molt cycle, there was a pre-alternate molt of the body feathers, which allowed it to change its color for sexual selection processes, brighter plumage to attract mates. So that's a good example of a pre-alternate molt within the definitive or adult molt cycle. Okay, so the first cycle is different. Now, there's a few reasons why the first molt cycle is different, and that's because it's longer. It's actually 14 to 15 months rather than 12, but between when the bird hatches from the nest and when it undergoes its first, or what we call its second pre-basic molt at a year of age. Second, the plumage tends to be very weak. We know this from juvenile feathers. There's a premium, especially on altricial birds that are raised in nests, to get these feathers grown as quickly as possible to get out of the nest, because the longer they're in the nest, the more likely they are to get predated by a snake or a jay or a corvid or something. So, that's why from egg to fledging is often as little as 12 days, which is kind of amazing. But they have to make some sacrifices there. And one of them is to create these very weak juvenile feathers just to get them out of the nest. And then within a month of life, they replace those juvenile feathers with a better coat of feathers. And that's a good strategy for them to be able to not have to live the entire year in these weaker feathers. Okay, Humphrey and Parks termed that inserted molt within the first cycle as the first pre-basic molt. And there was a big problem with this because it's very variable. Some birds do not have that molt in the first cycle. So then this molt, the first complete molt, became termed the first pre-basic. Others have it, even closely related species, and the ability to compare molts in an evolutionary sense was completely lost. So here you've got first pre-basic molts. They can be absent, partial, they can be suspended and protracted, they can be incomplete, they can be complete. So they're all over the map. And when you kind of confound these molts with the molts of adults, everything gets pretty confusing, and you're back to people avoiding molt altogether because it's just too hard to understand. In 2003, Steve Howell and others, including me, came up with another terminology for the first cycle. And so what we did was we redefined this molt into the juvenile plumage. So the molts, the birds that get feathers that get replaced in the nest, as the first pre-basic molt. So this molt is complete. And then therefore that allows all of the molts here to line up, and then us to define evolutionarily the inserted molts that occur within the first cycle. So juvenile birds undergo a molt in the nest. Their feathers, their body feathers are pretty weak, but they do molt all of their wing and tail feathers. They grow them in as part of a molting process. And so it's a complete molt, just like the others. So it makes more sense to call this the first pre-basic molt. Now we continue to use the term pre-juvenile molt because it's so ingrained and easy to understand, but it's kind of a synonym now of the first pre-basic molt. So that left us with this molt yet to define. If we call this the first pre-basic, what do we call that? We came up with the term preformative molt. So here we've got pre-basic, oops, I jumped the gun on that a little bit. Pre-basic molts are well defined. They're annual processes. They've been evolved from reptiles. And then you have inserted molts within the adult cycle and within the first cycle. Everything lines up and we're all happy now. And believe me, I used to teach workshops using the old system where that molt was called the first pre-basic, and I couldn't get anywhere. As soon as we changed the name to preformative to make people understand it's not the same thing as the pre-basic molt, it became very much easier to teach molt to students in workshops and banding classes and things like that. So again, getting back to the evolution of molts, evolved from dinosaurs. Pre-basic molts, yes. Pre-alternate molts have not part of the process that have been evolved from dinosaurs, because they have occurred in many lineages for many different functions. And we'll get to that in a second. Preformative molt, I think it might be evolved from dinosaurs. I wonder if perhaps young dinosaurs had an extra molt within their first year, as because their body was growing at a greater pace during that year. The reason I also think so is that the preformative molt occurs in almost all birds. There's 2 or 3 families of birds where we don't think it occurs. Some of the primitive ones like ostrich, vultures may not have it, New World vultures, albatross, but it might be there. We just, there might be a preformative molt there. And in some of these taxa, if it's gone, it's been lost evolutionarily rather than having evolved in the beginning. So the upshot is, I think that the preformative molt also evolved from dinosaurs. And so that gets you these 3 molts that have evolved from dinosaurs. And then within evolution of birds, you've got molts. Those molts are fixed. They seem to occur within all of these bird lineages. Here's dinosaurs down here. So all of these birds seem to have a pre-basic molt and a preformative molt, at least the great majority of them. And so the pre-basic molt cycle appears to be basal to all birds, first evolving in reptiles or their ancestors from reptiles. Might the preformative molt be ancestral as well, an extra ecdysis event in young reptiles to accommodate rapid body growth? Pre-alternate molts, by contrast, have evolved and have likely disappeared many times along bird lineages. So pre-alternate molts come and go. They're not part of this body restoration process. They just come and go based on the needs of birds. And we'll get back into that in a sec. So once we've defined the molts, and I know it's a little bit heady to have this terminology, but it's just so important to understand that it's an evolutionary process that defines the terms. The terms aren't based on breeding season, whether it occurs before or after breeding, location, extent, any of that, which a lot of the previous terminologies were based on those things. And the previous terminologies, by the way, were also rather boreal centric. So they work pretty well in North America and in Europe and Northern Asia. But once you get down to the tropics, those terms just make no sense at all. So that's why there was a need for this revised terminology. So large raptors like falcons and hawks, we discovered do have a preformative molt. It's a limited molt of body feathers. That was something that hadn't been discovered until we were able to sort out the terminology. Also, it was believed that herons and egrets, that these plumes that grow in the late winter and spring are alternate feathers or breeding molt. There was a pre-breeding molt, but it turns out there's only 1 molt per year in most of these, and that it occurs that the breeding plumes start to grow in late fall in October because they're replaced. It just takes them a little bit while to become this long and become noticeable. So people thought it was an extra molt in the spring. They actually thought that feathers were replaced with normal feathers first, and then those got replaced again. But there was really no time in herons and egrets to do that, and no need either. So what it is they're all replaced at once in the fall, and then these take a while to grow out and become more visible. Ducks, we were able to determine that actually the complete molt every year occurs into this plumage. So unlike scarlet tanager, the basic plumage following the pre-basic molt in ducks is the bright one in males. This is also an adult male in the summer, and what's referred to as eclipse plumage, but in Humphrey Park's terms, this is the alternate plumage because the molt was not complete. It's just a few feathers, most of the body feathers of the upper parts and what the reason this molt evolved is because ducks and waterfowl replace all of their primaries and secondaries at once. So they become flightless. So they need to be cryptic during that period of the pre-basic molt when the wing feathers are getting replaced. And then as soon as the wing feathers are half grown, they come into this plumage as well. So here's a case where the pre-alternate molt, unlike the tanager, is for a completely different purpose than sexual selection. It's actually for camouflage. And I actually think the same thing is going on with Jaegers, where this actually is an adult long-tailed Jaeger on the wintering grounds. It's not well treated, this plumage, because they're at sea in the southern hemisphere and nobody really studies them that much. But this is what they look like. But the important thing is this is based on a partial molt. Then in the winter, on the wintering grounds, they undergo a complete molt, which gives us the breeding plumage here that we see on the Arctic. So I actually think that this is the pre-alternate plumage here, and this is the basic plumage in Jaegers. Okay, so let's talk about molt strategies a little bit. Why and how do birds molt? Well, the obvious reason is to replace worn feathers. Feathers are keratin-based, they're dead, they can't be revitalized once they're grown in. And so throughout the course of the year, they become very, very worn. And I'm an adherent to the main enemy of feathers being solar exposure. I think the sun really degrades the feathers a lot, and you see the birds who spend a lot of time in the sun not only get more worn feathers, but also replace them more often because they are getting more worn. And we'll get to that in a second. So we've also seen that molts can evolve to add color for sexual selection purposes and subtract color for camouflage purposes. So these are the different reasons why molts evolve. But I think the primary undergoing reason, and especially for the pre-basic molt once a year, and for the preformative molt, is to replace feathers that become non-functional because they're too worn. So there was a debate for a while in that, why did the pre-alternate molt evolve? Well, one simple way of looking at it, for instance, in the American goldfinch here, is that the molt actually did evolve to produce the color for sexual selection. So sexual selection drove the evolution of the pre-alternate molt. Well, that's, if you think about it, that's hard to figure out, because how would it have gotten going? You know, it starts to molt, and then it's one bird starts to molt yellow feathers, and then that's what drives the rest of it. Meanwhile, there's many other species like wrens and flycatchers that undergo just as much of a pre-alternate molt. However, they do not change their plumage color very often. So what we now believe is that the molt evolved first to replace worn feathers, as in the wrens and flycatchers, and then the male American goldfinches took advantage of that extra molt to start producing brighter yellow feathers that then maybe enhanced the evolution of the molt a bit, but it wasn't the cause of the pre-alternate molt. And the reason, the key factor here, and this is something that is a problem too, is that molt studies often concentrate on males. Well, we can't ignore the females. And the females, it turns out, American goldfinches have the same molt have the same pre-alternate molt as males. They just don't change their plumage into the brighter color. So that indicates to us that probably the ancestral American goldfinch looked like this in both sexes. Because they're out in the summer in the sun a lot, they evolved a pre-alternate molt like other birds that live in the sun in harsh environments. And then the males suddenly some of them started getting brighter feathers in the alternate, and that's what drove the males to look different than the females during the breeding season. So molt extents, I won't go into too much detail here, except to say that it's all over the place here. Sometimes it's complete, sometimes the preformative molt can be complete, partial, absent. Pre-alternate molts can be complete or absent. If a second inserted molt comes into the cycle, we call that the pre-supplemental molt. That's generally not complete or almost limited to a few body feathers, but there's just a lot of variation in the completeness of molt. However, within our defined definitive cycle, we're able to then study these molts in a way that includes both extent and timing and location. So a lot of you are familiar with this. If you're a bander, the preformative molt in many passerines can vary from replacing a few lesser coverts to being complete. A lot of them replace most of these and a few greater coverts or most of the median coverts. And of course, this is a way in which we're able to age birds that we catch for banding. But the important thing is even within species like house finch of North America, you can have individuals that vary from A to F here in the extent of their preformative molt. Whereas in other species like Catharis thrushes and even thrushes around the world, the preformative molt is a little bit more fixed to between B and C. But you have all of this variation in the extent of the preformative molt. Here's a black-headed grosbeak of North America that's replaced all of these feathers during the preformative molt, the black ones, including some tail feathers as well. Okay, so this is a partial preformative molt. Let me turn off my dinger here. Okay, some molts can be incomplete, like the cardinal. Northern cardinal has a molt that is what we call typical sequence, and I'll get to sequence later in the talk. Starts with the inner primary and goes outward, but then arrests at a certain point before all of the feathers are replaced. And this is an arrested molt is it. So the next time it molts, it'll start again in sequence and then replace all of the feathers with juvenile feathers. We also have birds that in North America, we call an eccentric sequence. The definition of eccentric is a little broader in Europe, but here somehow the term's been limited to just this sequence, which is fairly common in North American birds, especially those that inhabit desert and drier regions. So this again is a preformative molt. Here's a lesser goldfinch. It starts with a middle primary rather than P1 and goes outward. And again, you can kind of see this happens in these birds that are subject to a lot of solar exposure, and it's replacing these feathers that are most exposed generally while it's doing its thing, while it's in its environment. Interestingly, with these molts, the primary coverts, this track usually doesn't get replaced along with the primaries. So this then turns out being a good way to age these birds with eccentric molts. Even occasional eccentric molts can vary to replace all of the primaries and secondaries, yet you still have primary coverts that are juvenile and you can age those birds. Now there's also incomplete pre-basic molts in the adult cycle. These occur primarily with larger birds, and it's because they do not have enough time within the molting season to replace all the feathers. And hawks and other large birds have developed this process where there's waves of molt that stop and then start again where it ended and continue. So you get these sets of feathers within the primaries and secondaries of different ages. And that's called Staphylmauser or stepwise molt. And it turns out to be a pretty common molting process in birds. I like this photo. I found it online. I don't know if it's real, but at least the molting process is real because both of these birds, great blue heron and bald eagle, are ones that exhibit Staphylmauser or this stepwise molt. And it turns out that it just seems to be a process that gets kicked off only by an incomplete molt to begin with, and then it starts. And it can happen in almost any species of birds. We've even documented in passerines and doves and nightjars, but it mostly occurs regularly in larger birds, seabirds, frigates, boobies, pelicans, herons, larger raptors and so forth. Okay, where and when. So we've seen that the extent of molts can be quite variable. So can the location. A lot of birds will molt on their breeding grounds or near their breeding grounds before migrating south. Others migrate all the way to the wintering grounds and then undergo the pre-basic molt. But a lot of species, it's turning out probably more than we think, undergo something we call molt migration. So here, for instance, indigo buntings breed here, and then they all go down to the monsoonal region of Southeast Arizona and Northwest Mexico to molt. And when they're done molting, they continue on to the wintering grounds. So this is called a molt migration. It's actually a 3-step process of migration: breeding to molting, molting to winter, winter back to breeding. So it turns out there's a whole slew of species that do this, that go down into the Mexican monsoon region. And the reason they do that is because in the summer down there, the habitat is pretty dried up and not productive. There's not a lot of insects. So there's not a huge number of locally breeding songbirds in this habitat. There's a few, some of the hardy, sparrows, cats and sparrows and things like that do breed in this, but there's not a high density of birds. Then, as we're seeing this year in particular, the pressure systems shift, and what it causes is these winds to come up the Gulf of Mexico. They're moisture-laden winds, and dump a whole bunch of rain in the monsoon region starting in early July and going through August. Well, then the plants all bloom. There's a huge flush of vegetation, flowering, insects. So there's a big resource down there for birds to take advantage of that's not filled up by locally breeding birds because they're kind of rare down there. Meanwhile, up here in the West or North America, as we know, July, August, September, things just dry out. And so insect abundance becomes less common. And then, so that's what drives them to go down there. We did a study down there in the late 2000s, and our results suggest that molt migration is a stochastic process. So it doesn't, when we started out, we just thought all birds do this, all birds do the same thing. Well, that's not going to be the case with molt, unfortunately, so it makes it a little bit more difficult. But individuals instead make annual choices where and when to molt based on breeding season dynamics, climate variables, and nutrient resource availability on both breeding and molting grounds. So in other words, if it's a good summer, there's a lot of food around where they bred, they might not molt migrate. They might actually molt on the summer grounds. Or if they get to the molting grounds and it's a dry monsoonal year, they might just continue on to the wintering grounds. So there's a lot of individual choices. And we actually found also that second-year birds, who probably more of them failed breeding, were more likely to be molt migrants than older birds. So that indicates that even at the individual level, the bird might molt migrate one year and not the next. So very plastic system here, molt migration. Okay, at this point, I'd like to wake up my audience to give a little quiz, and it has some relevance on what we've been talking about so far. And that's to name the 2 North American bird species that can have a complete pre-alternate molt. So as I mentioned, pre-alternate molts are largely partial, involving just body feathers. In Europe, you'd call it the pre-breeding.
No.
So but there's a few species, and in Europe, for instance, the willow warbler is one that actually goes to the wintering grounds and replaces all of their feathers for a second time in a year. But there's only 2 in North America that do this, and they are the bobolink and the Franklin's gull. Now, obviously, that, as I mentioned earlier, these pre-alternate molts didn't evolve only once to do this. They evolved separately within these 2 groups of birds, these 2 species. So what I like to ask is, why did these two species end up with complete pre-alternate molts, but not anybody else? And the reason has to do with both of them being birds of the sun. As I mentioned, they spend all of their time in the sun. In addition, both of these species breed in high or temperate latitudes in the north and migrate all the way down to South America, southern South America, to winter in temperate latitudes in the south. So what does that mean? That means that they're breeding up here in the summer, 16 hours a day. They're going down to South America to winter, but it's their summer down there, so another 16 hours a day. So on average, these birds experience a lot more solar exposure than do other birds that are resident, say, in one place, whether it's in North America or the tropics or South America. So a lot more solar exposure. And another thing that these two species get to their advantage is 2 summers worth of food resources. So the bobolink, there's plenty of insects up here in the summer to have extra nutrition to molt. And then they get down to the wintering grounds in South America, and there's plenty of insects there during their summer. And so in addition to having extra solar exposure resulting in the need to replace more feathers, they also have a greater amount of food resources to be able to molt all of their feathers twice per year. Okay, why is molt important? Here's a few things we'll go through. First of all, as I've already mentioned, molt leads us to be able to age birds effectively. So here's indigo buntings, and we can recognize these feathers and these feathers here as juvenile, whereas in adults, the primary coverts have blue edges. So that enables us to identify the ages of these two birds. And identifying the ages of the birds then leads to one of the cruxes of the MAPS program, and that's to be able to look at vital rates of North American birds, including productivity. So productivity is based on being able to differentiate young birds from old birds, what percentages of those birds, every year are hatched. So we come up with our productivity values by looking at that ratio, and that varies from year to year and species to species. And then also in survivorship analyses, we have to just base those simply on adults, so we can't include the young birds on that. Now here's a study we did in Alberta where we actually looked at 1-year-old males or 1-year-old birds, which we call yearlings, versus adults. And so again, molt limits, like this Canada warbler has juvenile feathers contrasting with the back. Here's an adult with all basic feathers. So enabling us to identify second year versus after second year birds then allowed us to figure out that the yearling proportion for birds that prefer forests was higher in scrubby habitats, and the yearling proportion for birds that prefer to breed in scrubby habitats was higher in forests. So in other words, second year birds, yearlings, are being displaced by older birds to have to go into less favorable habitat. And we can actually use yearling proportion ratio to identify higher quality habitats or source habitats versus lower quality habitats or sink habitats for each species that breeds. And that then leads to an emphasis of conservation on the higher habitat qualities for these birds. Now we have a coding system based on HP, and I'm not going to go into that right now, but I will mention it briefly that we just got a paper accepted that's going to hopefully stabilize the WRP age coding system. And so you'll hear more about that later. One of the things we had to do is add an adjunct code before the WRP code. But again, I'm not going to go into that too much here. The upshot, though, is that a lot of people are excited about this molt terminology, and it's an absolute necessity in the neotropics because the age terminologies based on calendar year just don't even work down there, nor do they work in the Southern Hemisphere. So what this paper is going to do, hopefully, is help define this system for use on a global purpose for all birds around the world. I gave a talk a couple years ago showing how molt is very important to our studies here at the Institute for Bird Populations. And for the woodpeckers, blackback woodpecker is one of our study species. Because we were catching birds as part of the study year after year, I could actually study the molt, how the feathers got replaced between years in individuals. And through that process, looking at primary coverts, I was able to identify 4 age groups of blackback woodpecker: second years, yearlings; third years, a year older than that; fourth years, and then after birds that are after 4th year. When we compared the ratio of those 4 age groups with the age of the burn, it turned out that really new burns, 1-year-old burns, had a preponderance of yearling birds in them, whereas older burns that were 6 years old had no yearlings in them and just had a mix of sort of older birds within the habitat. And I thought this was really cool. And the conclusions from this are that new burns are colonized by post-juvenile dispersal. So when there's a new burn, and this is especially relevant now with all the burns that are happening in California and elsewhere, the juveniles that disperse find the new burns. Then the old birds, once they find a new burn, appear to stay with the burn for their lifetimes. So it turns out that peak bark beetle larvae numbers coincides with peak breeding at 3 to 5 years. So a woodpecker usually, yearlings aren't very successful. 2 years, they gain a little experience. 3 to 5 years, they're very experienced. And that coincides with when the bark beetle larvae are most abundant. And then, so the burns and woodpeckers, then the adults after the peak breeding, they're older, they're getting senescent, they're not as, don't have that energy, you know how all that goes. And then they kind of ride off into the sunset together at 7 to 9 years. Now, I know they were trying to actually show that this is the case, or maybe not. And I've put in a few links here and there, and maybe Meredith can put them into the chat. But this talk, a recent talk by Morgan Tingley on this whole subject, is very, very fascinating. So it's online now at the link below. Okay, another thing we figured out was there was a vagrant great gray owl up in Northern California that could have represented a breeding population that we hadn't recognized yet. And then lo and behold, one turned up in about 50 miles away the next year. And so the question became, was that the same individual, which would just indicate a vagrant that, you know, isn't that important? Or could it be that there were more than one individuals in this area of Humboldt County, California, that might indicate a breeding population? So molts and owls are very interesting. They actually start in the middle and go both ways of the primaries and so forth. So I looked at all these images from 2016 and compared them to images from 2017 and was able to determine that it indeed was the same bird 50 miles away. So it looks like there's probably not any breeding population there, just one individual. And this was kind of cool too, to be able to see how many feathers exactly molted between the 2 years. And that helped lead to a better understanding of this species molting process. Another important aspect of molt is species ID. You've now got these cryptic species such as band-rump storm petrels, where on the same island, one population breeds in the winter and the other breeds in the summer. So otherwise, they're just about impossible to tell apart. So how do you tell them apart? Well, seabirds classically molt throughout the non-breeding period. So the timing of molt will enable us to identify the population, whether it's winter breeding or summer breeding. And by the way, we're just now looking at this in Ainley's storm petrel part of the leeches storm petrel complex here in the Pacific as well. Okay, conservation of molt migrant habitats. That's very important. We need to know where they molt, and then to be able to conserve their habitats. There's, of course, a lot of emphasis on conserving breeding habitats and wintering habitats, but I'm going to argue that conserving molting habitats is equally as important as conserving breeding and overwintering. And yet, because we really don't know where most birds molt, that's a problem. So we need to find out where they molt in order to conserve those important habitats. This was a result of our molt migration study, where we were able to actually look at molting birds in the Mexican monsoon region and we identified 6 different habitat types, and we found the places where these 12 species, and I won't mention them all, but a lot of you in North America know what they are, where they molt, and that's going to help us conserve those particular species by conserving the particular habitats in which we found them molting most. What about future research? Where else can we go with this? Well, where the heck do birds molt anyway? You know, we know about molt migrants that go to the monsoonal region, but what about all these other birds? You know, do they stick to their territories or not? So what we did was we used MAPS data to look at individual birds and how often an individual that was caught in breeding condition on the MAP station also molted there. And we found a big variation in whether or not these species do. And the upshot of it all is that a lot of species have large percentages of birds that leave the breeding grounds and molt elsewhere. These maps show breeding areas based on MAPS data in blue and molting areas based on MAPS data in orange. So lazuli bunting, you know, shows the classic molt migration strategy process, but we also found that orange crown warblers, for instance, go up into the Sierra to molt. That was known already. So these undergo upslope migrations. American goldfinches tend to go south to molt. Swainson's thrushes in the east that breed up in New England and the maritime Canadian provinces tend to go to the Mississippi Valley to molt. We found upslope migration in Acadian flycatcher. We found that red-eyed vireo is supposed to molt primarily in South America, but we found a bunch of molting in the southern US as well. So through this data set, we were able to identify basic molting, that a lot of these species that were thought to molt on the breeding grounds or the wintering grounds actually go elsewhere from the breeding territory to molt. That makes sense because they probably exhausted the food resources on their breeding territory. And also molting requires different habitats. It requires thicker, scrubbier habitat in which the birds can hide to replace their feathers. And it might also require certain nutrients that might not be found on the breeding grounds to be able to produce feathers. So it makes sense that birds are not going to molt when they breed. So the next step we need to do with MAPS data is to analyze habitat choice by molting birds in order to conserve molting habitats. So a lot of the banding stations have habitat data that we've rigorously collected, and we can also look remotely at habitat now. So what we want to do is look at birds that look at MAP stations in which a species molts but doesn't breed, and compare it to MAP stations in which a species breeds and doesn't molt, see what differences there are by habitat, and thereby identify the habitat in which the molting birds need to undergo molt. Okay, so digital imagery, that's become a real important and great tool for the study of molt. We just, you know, it just is amazing now how crisp the photos are, how close they are, how you can identify every feather, you can identify every feather generation. A bunch of years ago, I wrote a little paper here on how to do this, and you can actually look at digital images and identify feather generations, whether they're juvenile or alternate or formative and age birds now in the field. So instead of having to catch birds, I think future studies can just take digital cameras and go out and start snapping pictures of birds. And then you can get age ratios potentially just by looking at the images. Recently, I did a huge study. I call it a rabbit hole, and I'll explain that in a little bit, in which I looked at over 25,000 images of 8 species of North American hummingbirds to see if I could figure out molting strategies, because they weren't really well known there. And I used the Macaulay Library, which is Cornell University library, and was able to look at, for instance, on broad-billed hummingbird here, over 8,000 images to study molt. And so that's become a big resource for me to go to when I have a question about molt, and I'll explain that a little later as well. All right, so we've learned that timing of molt is hormonal, location is plastic. All 3 of these parts of a molt strategy are very plastic. What about sequence? Well, it turns out sequence is different. It's much more fixed in birds. So almost all birds, I'd say 90% of birds, start with the innermost primary, P1, and molt each feather sequentially to the outermost primary, P10 or 9. And that's just how they molt. Secondaries also are molted in a very fixed way, in which the second tertial, S8 in passerines, drops first, then it goes to S9 as well as S7. And then meanwhile, another wave starts at S1 and comes this way. Now, whether or not where the 2 meet, it could be S6 is usually the last feather replaced, but sometimes it can be S5 or S4. But the important thing is the direction, the nodes, which are where the molt starts, S8 and S1, as well as the direction is fixed, P1 outward. Well, a few birds don't do this. They molt some weird, I've already mentioned the owls that have a weird molt strategy. And in 2008, this paper came out in Science that basically overhauled our understanding of the phylogeny of birds. And one of the big noticeable conclusions was that parrots and falcons both were closely, not only closely related, but were more closely related to passerines than, say, falcons were to other raptors, which was what was thought before. So you've got parrots and falcons being closely related. And I said, no, wait a minute, both of these molt differently than normal. They start in the middle of the primaries, P4 or 5, and go both ways. And then they start at S5 of the secondaries and go both ways from that. So there was pretty good information on falcons, peregrine falcons and others on this, but not good information on parrots. So I went through to all the museums and actually documented that not only do parrots and falcons have that similar molt strategy, which is kind of unique, but also that it's found throughout all species of both families. And so we're talking over 300 species of parrots, with one exception, the strigops or kakapo or owl parrot of New Zealand, which is a really weird parrot. It's flightless and lives on the ground, had more of an ancestral strategy like other birds. So what that means to me is that falcons and parrots, this molt strategy in falcons and parrots go all the way back in evolution to before the parrots and falcons split. So that just shows how fixed sequence is, flight feather replacement sequence is in birds overall. Now it's possible that the owl parrot, it is also the most primitive of the parrots. So it's possible that the other parrots split from the owl parrot before the other parrots, the falcons, split from the other parrots. Or it might be possible that the owl parrot, because it's so weird, just switched its molt strategy again sometime along its evolutionary path. Okay, so another one thing we've noticed is that limpkins molt their feathers backwards. That's kind of weird. They start with P10 and go inward. And we thought maybe it has to do with this outer P10 needing to change shape for the limpkin to snap, because it snaps its wings as part of its courtship. But it turns out that all of the family Gruiformes, which includes cranes and rails, also molt backwards. So again, you see that this backwards molting evolved very early, probably within Gruiformes, and that all of the cranes and rails and limpkin and a few other families within that order ended up also molting backwards, again, showing how fixed the sequence is. So yes, sequence is rather fixed. I think it's probably got a neurological basis to it, not a hormonal, but this is just something that's very poorly understood. You know, for species that exhibit Staffelmauser, they'll go out to a certain point in their primaries, but then they wait till the next molt, but somehow the bird knows to start at that next primary rather than starting over again. So how does that work? It's hard to know. A real good study for those who are into neurological or chemical biology to try to figure out. Where do kingfishers molt? Well, it turns out very few specimens are available of kingfishers in molt. And we think now that a lot of them anyway probably go into their breeding holes after breeding and molt all of their feathers in the breeding hole before coming out. Now, of course, that would be something that would be very important. And I've studied this with birds in Marin County, California, where I lived in the Bolinas Lagoon. And sure enough, the breeding pair gets the chicks out. It's a big ruckus when the chicks go. And then the adults just disappear for a month. I don't see them. And then all of a sudden, there they are, same adults, same perches, same everything, brand new feathers. So I think that there is a possibility there that kingfishers, at least belted kingfisher, goes into its nesting hole, undergoes maybe a complete flightless type of molt like other birds, and then comes out. There's interest in how feather color varies with timing of molt. So we call it a molt-plumage interaction. And that's another area ripe for study. For instance, in adult male summer tanagers, they usually molt from red to red to red. However, if the molt starts a little bit early, like this bird, the first feathers to be molted in, and in this case, you know, it's the ones we know, the inner primaries, come in a little bit yellow. So this bird probably started molting in June. And meanwhile, if the feathers are replaced in July through October, they come in bright red, and that's when most of the summer tanagers molt. But then here's one that might have molted a little bit late. So the final feathers to come in on the breast may not have come in until October or November. So that's a real interesting thing that we know very, very little about. And I actually have used this color change in a recent manuscript that I've written to try to help define molts that occur on the wintering grounds, in particular in these young male summer tanagers. What about molt in tropical birds? There's a whole world of species out there in which we don't know nothing about molt, you know, and so we're really, I think in the past 10 to 20 years, been focusing a lot on molt in birds of the neotropics, you know, how do they vary? And it turns out that molts in the neotropical birds are very similar to molts in the same families that occur in temperate regions. So that's you know, our understanding of that is really increased. This book here by Eric Johnson and Jared Wolf really goes into it for, you know, a few hundred, 100 or 200 species that are found in Brazil. So we're moving along in that direction. And as part of that effort for our MOSI stations, which Meredith mentioned, they're stations that occur, that we have banding stations throughout Mexico and Central America, having the banders take open wing photos, because this is where all the action is on variation of molt for future study. And now we've got catalogs and so forth that we're able to put these online. So anyone can go in addition to Macaulay, anyone can go to Parenga is one of them up in Canada, where you can go on and study molt patterns in various species. So I've been encouraging people who band at the Mosey stations to take these photos, especially if you see feather generations of interest, and upload them to these catalogs. So the conclusion of this part of the talk is that don't be afraid. Molt can be fun. I know it's a little intimidating and there's a lot of crazy stuff that goes on about it, but there's also a lot of neat stuff. And then I think once you understand some of the things I've been talking about, the way the process works, the terminology and so forth, it becomes a lot easier to appreciate molt and to actually understand it and to study it. Before I get to questions, I did want to circle back to what Meredith said, that I am going to be revising identification to North American birds. I'm about in the process of it. So of course, as always, takes longer than I'd hoped. One of the reasons is because I go down rabbit holes. And this is a talk I gave recently. I think there was a link already to it on hummingbird molts, but one of the rabbit holes was hummingbird molts. And I just had to go down and figure out those 8 species and look at 25,000 images. So that delayed the revision by a month or 2. Another rabbit hole I'm currently in is subspecies. Now we will be having another, hopefully if this worked out to everybody's happiness, we'll have another session like this, maybe in the winter sometime, on what I'm doing with my revision, some of the changes you'll be seeing and where it's at and everything. So stay tuned for that. Okay, questions. And before we get to the ones in chat, Hannah Suthers of New Jersey had sent me a couple of questions, and said, my questions are too complicated to type in at the end of the webinar, so I'm submitting them now. And she also submitted a couple of photos. So I thought I'd start with these 2 questions from Hannah, and then we'll open it up. So is this great crested flycatcher an AHY or an SY bird? No, it's molting normally on August 17th. It's replacing outer primaries. It's almost finished, and it's almost finished with the secondaries. But what's unusual is that these 2 primary coverts did not get replaced when their primaries got replaced. So that's a little bit odd. Is it a second-year bird or not? That would depend on if these feathers are juvenile or not. So great crested flycatcher molts all of its feathers during the preformative molt, except for the primary coverts. So I'm kind of thinking these look a little worn and brown for this time of the year. So they might be juvenile feathers, in which case it'd be an SY bird. And if not, if we decide they're basic feathers, we can call it an ASY bird. But I don't think we know. We still need to study enough on that to know, to go the difference. And what would the WRP code be on such a bird with an arrested molt? Well, if it ends up arresting so that these 2 primary coverts are retained, then it's either undergoing its second pre-basic molt if those are juvenile, so it would be coded SPB, or it could be undergoing a later molt, TPB. And for a bird that we can't decide, that's why we put in this code minimum. So it's at minimum a second pre-basic molt bird. So that's the equivalent of AHY that we don't know if it's an ASY or an SY. I won't go into a lot of detail there. So is this a hatching year male or a second year female northern cardinal? How do you code birds undergoing the first pre-supplemental molt? Okay, so as I do now, whenever I get a question like this, I don't know northern cardinals very well. They don't occur here in California. So I don't know if the answer to that first question. So, but what I did is I turned to Macaulay and said, okay, and I filtered for June in New Jersey, and I filtered for New Jersey, and there are 134 images at Macaulay of northern cardinals photographed in June in New Jersey. So I found what looks like a young male here and an SY female there, and I would say this matches up better with the SY female. I think these feathers are too worn to be juvenile feathers in June. So let's call it an SY female. Plus, the other thing for me, at least, was to see that females can have brighter red, lesser coverts and greater coverts like this. So everything to me matches up with this being an SY female, not a HY male. So what about the WRP code? Had it been an HY male, there's a question, because Northern Cardinal is interesting in that it has an extra molt within the first cycle. And in the ID guide and elsewhere, this is called the first pre-supplemental molt. I don't know a lot about this molt. Eric Johnson, who I mentioned in Louisiana, knows more about this molt. But we have actually accounted for it with our WRP codes. We have an FPX undergoing the auxiliary preformative molt, and FCX would be in that plumage. Now, we had to change the name, first pre-supplemental, because it turns out that some birds like least tern and ptarmigans actually have a first pre-supplemental molt, which equivalates to the ones that are in the adult cycle. So we had to come up with a new term, and it's what we call it the auxiliary preformative molt. Now, there's another question: is if the preformative molt is overlapping the auxiliary preformative molt, which can happen, what do you call it then? And that's an FPF. This is really in the weeds, I know, but and at some point we'll do a whole webinar on WRP coding, maybe along with the one I do on the revision of the guide. So anyway, I want to thank you all for attending, and I'm happy to stay the full 2 hours here. What do we got here? An hour and 10. So we got 45 minutes or so where I'm happy to answer questions, and I'm also always happy to take them when you, if you want to email me or have her. So Meredith.
Yeah, I'll jump in. I'm going to start asking for the questions that were given during the chat during the presentation. I'll also note that at the end of October, we're hoping to have another webinar that will be about some of our work with native bumblebees. So if you're interested in that, I will be sending out an email about it. And so let me go to our questions. So the first question came from Judy, and she asked, in birds that migrate long distances, it seems that they would need to rely on strong flight feathers to increase their chances of getting to their destination. So why in the preformative molt are the weak juvenile body feathers replaced before this journey, but not the seemingly important flight feathers?
Yeah, so that's all. There's several questions there, and
yeah,
all good. And so the juvenile body feathers are so weak that I don't even think they would last the migration. So for most birds, those feathers, passerines, those feathers are indeed replaced within a month of fledging, and they're replaced on the wintering grounds. A lot of birds don't do that, though. They grow stronger juvenile feathers. And examples, outside of the passerines of that might include raptors and seabirds. And we think that because those birds generally are not subject to nest predation, and burrow nesting seabirds especially can afford to have a longer pre-fledging period and be fed also highly rich food, so that allows them to molt, to have keep those strong juvenile feathers throughout the year. As far as the flight feathers go, there seems to be more energy put into them in the nest for most species. As we know, most first year birds keep their juvenile flight feathers for the first year. So it seems that to undergo a complete preformative molt might be too much for many species, but not all species, because there are a number of species that we know about: starling, European starling, and wren tit, and bush tit, and snow bunting, or not snow bunting, I'm sorry, hornlark. There are a lot of species that do undergo a complete preformative molt. And I would venture to guess that those species have the resources on the breeding grounds to undergo the preformative molt. Now, the second part of the question is why wait till the wintering grounds to replace them? Most of them, a lot of them don't replace any more feathers after migration, but some do, and this is important. A lot of species, the molt migrants and others, will suspend the molt for migration and then resume it on the wintering grounds. And this is kind of a problem with the terminology. With the older terminology, is it doesn't really account for that. So under Humphrey Parks, we call that a suspended molt that stops on the wintering grounds and then stops for migration, completes on the wintering grounds, and then actually will sometimes even overlap pre-alternate molt on the wintering grounds. So anyway, that's there's all this variation in the strategies as we've seen. And I think the bottom line is it depends on the environmental conditions that the birds face. How much breeding, how much food to molt is there on the summer grounds? How much food is there on the wintering grounds? Or do you need to go to a third place entirely to replace the flight feathers? So I hope that answers the question.
That's great. So our next question, I'm combining two questions from Alejandra and Camilla. They were asking, why does partial or incomplete molt occur? Is it specific to species or some effect of the environment?
Yeah, again, the same kind of answer that I just gave there. If a bird is exposed to a lot of solar radiation, I believe those are the ones that most often undergo the incomplete molts, because especially the tertials, for instance, get replaced a lot in birds. They'll often get replaced twice per year. Those, it turns out, are the most exposed feathers on the entire bird. They cover the wing. They're very important feathers. And so oftentimes you'll see a bird, when it undergoes an incomplete molt, will replace those tertials and outer primaries, and those feathers that not only are more exposed, but also more functional and needed. So that kind of explains why incomplete molts occur. So then when you look at this at the species level, all these species have many different environmental environmental situations that they face, and the molts tend to get evolved based on the environmental conditions. So where it molts, how many feathers it molts during an incomplete molt, and the location of where it molts, all of that, and the timing of when they molt, all of that has to do with the environmental conditions that the species as a whole face. But then within that, the species, you also have a lot of individual variation, which adds to the complexity of the whole thing. Now that's timing, location, and extent. And as I mentioned, the sequence is different. It's pretty fixed. So when a bird does undergo an incomplete molt, it's usually the same feathers across species that are not molted. The outer primaries, often the middle secondaries, the outer rectrices, and lower body feathers that are lower on the rump, for instance, often are the ones that don't get molted when a bird maybe doesn't have enough time to molt or just undergoes an incomplete molt, because that's what it does.
All right. So we have another question from Manuel. In regards to solar exposure, do savanna sparrows living in salt marshes have a more extended molt than those living in pastures or less arid habitat?
I believe they do. I believe that, I'm trying to remember savanna sparrow in particular, but there's a large-billed sparrow, which is the subspecies of savanna that breeds down in the really exposed and open areas of northern Baja California and the Sonoran Desert. And if I recall, they do have a more complete preformative molt. It includes more often includes tertials. I know this happens also in song sparrow, where the song sparrows that breed up in the Alaska, they're resident on the Aleutian Islands in Alaska, do not molt as many feathers as the ones that migrate or the ones that breed down in Arizona, for instance. Those song sparrows either may or may not undergo an eccentric molt. They might or might not replace outer primaries, and the proportion of birds that replace outer primaries up in Alaska is 0, and the proportion that replace them in Arizona is maybe 40%. And then if you look all the way along through California, it's pretty clear that the more arid the habitat that the bird inhabits, the more feathers it does replace during the preformative molt. And common yellowthroat is another species that seems to show that variation, as do a lot of birds that have wide latitudinal ranges of breeding.
Okay, great. This is sort of an on the same theme question from Alexis. If the bobolink and Franklin skull experience heavy solar degradation of their feathers because of long migrations and therefore undergo 2 complete molts per year, why don't birds like bar-tailed godwit and Arctic tern, famously long migrators, also undergo 2 complete molts for the same reason?
Yeah, good question. One I really thought about a lot. First of all, I'm not convinced that Arctic tern does undergo a partial. I don't know that we really know the answer to Arctic tern. If it undergoes a complete molt, it could undergo 2 complete molts, and we just don't know it because of where they winter along the pack ice in the southern hemisphere. And there's been just incredibly few specimens collected of them during that period. I'm hoping that people will be photographing them down there, and we may even find out that Arctic tern has a complete molt. Because that's one that's puzzled me as well. The bar-tailed godwit has a real interesting bunch of molt. It does molt, let's see, what does it do? It has a pre-alternate molt. Yeah, the preformative molt, or let's see, the pre-alternate molt is partial in that it's not complete. So it just has to probably do maybe with the fact that their feathers aren't quite as exposed or there may actually be a little bit of a phylogenetic component to it, because no other shorebirds have 2 complete molts. I would guess the answer is in the real details, the fine details of the how much solar exposure they actually are exposed to, and other factors. Now, I think the bobolink and Franklin's gull example is good because it goes that way. They're the only 2 we know of that do this, and they share all these things. But that doesn't mean that other species that share those things don't do something else.
Okay, great. So this next one is a little bit more nitty-gritty weeds, and I'm hopefully reading it correctly, but it's from Manuel, and he asks, can you explain which WRP code would you use for a house sparrow molting if you're not able to see the skull? FAJ is an option, but as it molts, should there be a P in the middle letter code?
Oh, Manuel. I will, that's coming out in this paper. We're going to drop FAJ, and we're replacing that with this auxiliary code M. So the answer to your question actually now will be M. At minimum, it's undergoing the preformative molt. So the answer would be M FPF. And I know WRP is already squirrely enough for everybody to try to figure out, well, this is adding the extra letter is going to at first seem like it's making it even worse. But I think once people get used to that extra letter, they'll see that it's very functional in answering questions just like that. So so an AHY bird, for instance, in the spring where you don't know if it's an SY or an ASY, would become an M-FCF, minimum of FCF. Now, a lot of these, one of the things we're doing with the WRP coding is we have these core codes, which are, about only 7 to 9 of them. which we are going to really strictly define. But then we've got options for how to define unknown birds. So when you don't know the age of the bird, you can either use an M code or you can use a U code. But in either case, it'll allow the elimination of those birds from data sets where you just want to use the birds that were confidently aged. So that's another kind of aspect of what we're trying to do, is really establish 7 to 10 core codes that people can use a lot. And then the unknown codes, when you're not sure, you have more options to use. But in all cases, they'll eliminate them from the final data analysis that you want to use just the aged birds on.
Great. So our next question is from Heather Hill. Has there been any work done with programs like MODIS to better determine molting stopover sites? And you might want to explain what MODIS is for those of us who are not familiar with the acronym.
Somebody else can do that.
Okay.
MODIS, I presume it's some sort of a geospatial online thing. But yes, like for instance, I guess this might be getting at it, would be looking at eBird records, because they produce these graphs now that actually show migration. So I think Brian Sullivan did something with Orchard Oriole, which is in fact a molt migrant. And I think if you kind of look at the records in eBird, and now there's so many records being accumulated now, that you might be able to really see where all those birds go in August and September, how long they stop, and then whether or not, when they go to the wintering grounds. So yes, I think with all this new technology, we're getting to, tracking devices, records online, giant data sets. I think we will be able to make some progress on things like that question.
Okay, thanks. And excuse me, if you are interested in the details on MODIS, it looks like Kirk and Paz just put in some info on it and a link so you can check out exactly how that system works. So our next question is from Michelle. And she asked, as our understanding of molt becomes better, is there a chance that all bird species will be able to be reliably aged by molt limits eventually?
Not all, because you'll get ones that don't molt, that have complete molts and stuff, and there won't be molt limits. So there's those cases. Yeah, let's see. Well, right now it's subjective because it depends on the human's ability to differentiate a juvenile feather from a basic feather. I would guess that yes, that someday maybe you'll be able to snip one barb and put it in a little device, and it'll actually confirm whether it's a juvenile or a basic feather. So there's, technology is amazing how fast it's evolving right now. And I would guess that I still wouldn't say all, I'm never 100% guy, but if you can get 99% or 98% aged confidently, that's going to be just fine for analyses. So I guess that's my answer to that.
Okay. So then we have a question about ducks from Manuel. Any hypothesis as to why ducks go north to molt? I saw that while tracking ducks with Argos.
Yeah, it's because, so ducks undergo a molt migration. It's different from the monsoonal one. As I mentioned, ducks replace all their primaries and secondaries synchronously all at once. So they become flightless for 3 to 4 weeks. So what do they need to do to survive predation under those conditions? They need to go somewhere that's remote. They all tend to go to the same place, so that, Canada geese, for instance, will go up to an edge of a water body or some place up in the Northwest Territories. If they all do that, there'll be thousands of them in this one area molting. And then even if there is a predator, a fox or a wolf or something that gets a couple of them, it's not going to get them all. It's not going to get a very many high proportion. And they also need to find places where they can be hidden or where they're outside the reach of predation. And so a lot of ducks go into big, extensive marshlands and hide in the marshes. And geese and others that go north up to the tundra tend to find these really remote places in like big lakes and even marshes or bogs up there to molt. So I think they probably have a better chance of finding those conditions by going north than they do by going south, where there isn't as many remote areas, and at least now habitat's not as nice and so on. So I think that's the answer to why most waterfowl, but not all, do tend to go north.
Okay. So we have another question from Manuel. Do the flightless birds molt in the same manner as rails? Could that explain evolutionary sequences?
Yeah, I think they do. I think that when you have a rapid molt in ducks, you'll catch birds, rails, ducks, alcids during their molt, during this, I call it synchronous. A lot of people call it simultaneous molt, which means every feather drops at once. But if you catch birds in molt, not every feather drops at once. And, in fact, they tend, in my experience, to molt in the same sequence as other birds, P1 out to P10. It just happens within a day or two rather than over several months. So they all get dropped, but I think that underlying sequence is still there from what I can see. So yeah, they've evolved to have a quick molt and become flightless, but it doesn't mean they've lost that underlying sequence of molt that seems so fixed in birds.
Okay. So our next question is from Kirk, and it's, with the tanager color being based on timing, is that based on the seasonal availability of carotenoids in the diet?
Wow, you guys, this is great questions. I'm glad you're asking them. Yeah, for the red feathering it is, but there also is clearly a hormonal basis to it as well, where it's interesting in housefinch, for instance, you do see a lot of red and yellow and orange variation in the reds, which I think has been shown to be based on diet pretty strictly. But in summer tanagers, they don't, whatever it is, whatever that process is of incorporating the carotenoids into the feathers, it seems to be a little bit more fixed or a little bit more developed than in the house finch, for instance, because almost all the summer tanagers you see, the male summer tanagers, are bright red, and there's not much variation. It's only a few of them that you see these yellow or green feathers in them. And so, it could be that whatever the carotenoids are only available in July to October. You could push that hypothesis, but to me that seems a less likely explanation than that there's a hormonal process as well, or maybe the two interact that produce those red feathers no matter what. And then in the other times of year, they come in green. Again, when a summer tanager loses a feather and regrows it in say early spring or winter, it comes in green rather than red. It could be related to carotenoids for sure, but I would guess that it's also related to the hormonal functions of plumage deposition. And we've seen it in, say, the image I showed of the common murre. In that case, it seems like the feathers are coming in black if they're molted too early or too late during the pre-basic molt, because the signal for a dark head, a black head, alternate plumage, seems to go pretty long. So in that case, you've got the same effect going on, but it doesn't involve red feathers or carotenoids. So I do think that hormone, or that underlying hormonal pigment deposition cycle thing is happening as well in
Um,
summer tanager.
so Antonio jumped in with a comment on this question that you just answered is oxidative stress rather than hormone process. Said related to the present question, oxidative stress better than hormone process, question mark?
Maybe. I don't know a lot about oxidative stress. I know that oxidation of feathers will change their color, and we see that in cattle egret or cranes, Saniel cranes and so forth. But to me, it's a different process than that underlying color. You know, an alternate feathers one color, a basic feathers another color, and this happens in a lot of birds. You know, warblers and tanagers and so on. I think there's a grander function under there that has to do with plumage deposition cycles. And there are some really recent papers, which I haven't had a chance to digest, that are starting to explore how that pigment deposition stuff works.
Cool. So we had a question from Paz in the chat, and she may have gotten her answer. Marcel responded to her, but I'm going to ask you anyway in case you have something to add. The question was, is it possible to contribute to the ALAS open winged catalog? We have a banding station in Costa Rica.
Yeah, I would direct you to the Paranga site in Canada. I think they're good. They accept Marcel. Yeah, correct me if I'm wrong, but I think they accept birds from all over the world now. You know, I had an idea when I first had that idea for the ALAS program. I think it was in the early 2000s, and it just sort of never took off. And I don't, you know, it needs someone to really manage it well and correctly, and so you need a whole program like that, not just me. So that's what I would say to do now.
Great. So we have a question from Jan. Based on the blackback woodpecker study you mentioned, to what extent do you think presumed age structures can actually be partially the result of individual variation in quality and thus ability to molt rather than actual age? With that, how critical do you think it is to follow banded birds of known age of various prime and suboptimal in good sample sizes to account for these possible issues?
Yeah, well, that's a good question. The woodpecker molt does seem pretty fixed, at least for the first 2 to 3 years. You see it across all species worldwide so far that I've looked at, even wrynecks and piculips and things that are within the order Picaformes. Not all of the families in that order do this, but at any rate, it's again, evolutionary seems to be pretty fixed. So first cycle, second cycle, I don't see very many exceptions amongst all woodpeckers. So my guess would be that it's not a factor in variation in the age structure of blackback woodpeckers. We weren't able to identify all the third cycle birds because some do have a complete molt. So there might be something there where the bird that does undergo a complete third pre-basic molt undergoes a complete third pre-basic molt might be a better quality than those that don't, and that might have affected our data set there a little bit. But my hunch is that variation in the extents of those molts, which then indicates variation in the quality of the individuals, is not the major factor in our findings for that paper. I think it makes a lot more sense that there is these actual age structure differences that occur because of these different rates of post-juvenile dispersal, and the fact that once they do tend to find their burn, it seems like they're sticking to it. But again, I mentioned that talk by Morgan Tingley, which I think you should check in on, because he covers not just that subject, but a whole lot of other stuff. But you know, they're really they are getting some new information on these questions, which might be helping to answer that question.
And I'll note that Morgan's student, Andrew Stillman, just published a paper that we wrote up on our blog about natal dispersal in young blackback woodpeckers that kind of relates to some of what you were talking about. So you can go to our website to check that out. Our next question is from Herb. What book or books would you recommend to learn more on molt?
At a general level, the Steve Howell's book in 2010, you can find that online pretty easily, gives you a very good foundational basis for molt in different families of North American birds. And if you want to get into the weeds, then the My Identification Guide covers North America. There's a good series in Europe, Jenny and Winkler. They just revised their older publication from 1994. And so I would recommend getting that. That's got a very thorough introduction on molt and all these things I've been talking about today. They do use the old terminology, so I'm a little bit of a warning from me on that. But I know those of you who are used to the European terminology and what used to be used here more in North America, will find it, very thorough.
Great. So a comment and a question from Timothy. Some birds migrating to Northwest Mexico may actually breed there. I wonder how that might affect molt.
I think that's kind of been disproven. There was a paper on that, a decade or so ago, but I think it ended up, they had to publish a retraction on that. Now, that doesn't mean that some birds don't do that. I think Phainopepla is one that could do that. And here in Western North America, grasshopper sparrow may breed once, say come up to the Central Valley of California, breed once, get chicks off, migrate again to the coast where it's foggier and doesn't get as hot and dry, breed again. I mean, there's some anecdotal evidence to that effect. Yeah, if these birds that do that, I would guess would not molt between the two events. So they would breed somewhere, not molt, breed a second time, and then molt. That just would be my intuitive answer to that. We do see species in the monsoonal region that do seem to start a molt and suspend it. We've seen it in white-eyed vireo. We've seen it in canyon towhee. We've seen it in one or two others where, not white-eyed vireo, I'm sorry, Bell's vireo, canyon towhee, maybe cardinals down there, where they'll start the pre-basing molt and molt one or two feathers and then stop. So they've actually suspended the molt. And what we think is going on is that these are resident species, so they breed once during the hot summer. And then maybe when there's a good monsoonal season, they'll decide to breed a second time. And meanwhile, they've already started the molt after the first breeding attempt. They suspend that molt, breed a second time, and then continue with the complete molt after that second breeding. So there is maybe something going on there, just another one of a million things to look further into.
I think this is our last question, unless anybody wants to jump in on the chat. This is from McKinley. What is your process for determining molt in species which have been relatively unstudied?
Yeah, well, it used to be to go to the museum collections, and I'm always fascinated by that, going in and finding a family that we don't know anything about and trying to figure something out. One of the analysis we hope to do in the future is to really look at the sequence question throughout all birds and try to map how and when the sequence has changed evolutionarily. And to do that, there was a bunch of families of birds that there's nothing known on. The Wolf, Eric Johnson and Jared Wolf book looked into it for several neotropical species in which very little was known. So that was kind of fun. Or families, I should say. So yeah, eventually we'll get there. Now, the big thing I'm pushing now and doing now is going to Macaulay Library. Even these weird, unknown, hard to see families and species of birds, you'll go there and you'll find hundreds of photos to be able to look at, and you can look at it through the seasonally, and really look at feather detail to see how much how extensive preformative molt is, whether or not they have a pre-alternate molt, and questions like that, whether or not molt can be suspended, what the sequence is in the primaries. That hummingbird paper that I wrote, it's in review now at Wilson Bulletin. And also, by the way, I put up a preprint version of that, so you can go online. BioRVX is the place. If you Google it, you'd probably find it. And it's kind of a primer on how to use the Macaulay library to really study molt. And so I did it successfully, I thought, in these 8 species of hummingbirds. But you can do that for almost any species in the world now. There's over 30 million images now in Macaulay. And so any species you pick, you can at least find a few and start to learn about molt.
We just had another question in the chat from Manuel and he says, Peter, one question, do you consider WRP an age classification or a molt classification terminology?
Yeah.
Probably you will respond age classification based on molt, but I would love to have your opinion.
It's first, I would say it's first an age classification system, because that's what's most important for these studies, such as MAPS and other studies where you need to look at yearling proportion ratios or productivity analyses. So that's the most important thing. And we've built into the system lots of flexibility to put in U codes. So if you're, if all you care about is age, then you can, that first letter, F or D or S, tells you the age right there. It doesn't, you don't have to go farther than that. Then if you're also interested in molt studies, you focus and make sure to enter that second code. And then the plumage studies as well will allow you to know what proportion of birds, or when birds get into alternate plumage, the timing of that, and so on. So my answer would be first an age classification system, secondarily a system that allows us to study molts and plumages.
Great. If we don't have any more questions, I think we can probably wrap this up. We're going to get shut down in about 13 minutes anyhow. And I just wanted to thank everyone for attending. There were so many great questions, and it was really fun to see those and to see Peter's presentation. Since you guys registered, you are on IBP's email list. So we may email you, and I promise it won't be very often, to let you know if there's another webinar coming up, or there's a blog post about some research that we're doing. And you can always unsubscribe from those emails if you don't want to get them. I will be sending out an email when I get the recording of this webinar posted on our website, just to let you know that it's available if you want to go back and look at it. So thanks everybody, and thank you, Peter, for such a great presentation and answering all these wonderful questions. And I hope you all have a great rest of your Thursday. Bye, Peter.